Welcome everyone. Today we will explore the fascinating world of numbers and their representations in the various number systems used by computer programming and coding. We will discuss how understanding these number systems can help us solve complex math problems, while improving our logical thinking skills. Let's get started. Numbers are a ubiquitous part of everyday life. We are going to delve into the realm of number systems, from decimal to binary to hexadecimal. By understanding these various ways numbers can be expressed, we gain the capability to address complex math issues, refine our logical thinking, and fine-tune our computer programming and coding skills. Embark on this exploration with us and let's discover the remarkable world of number systems. The decimal number system is extensively employed in computing and programming. Being the most commonly utilized number system globally, it is structured on influencing of 10, with every digital implying an alternate spot worth in a number. This permits us to speak to numbers with more noteworthy precision and accuracy, permitting us to take care of convoluted math issues all the more effectively and productively. The decimal number system is basic for PC programming and coding, to help take care of intricate math issues and upgrade basic deduction aptitudes. Binary number system is the core of computer programming. It operates on a BASE2 system, using only two digits 0 and 1. Each digit stand for a power of 2 like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2 and so on. To get the decimal value of a binary number, you just have to add up the values of the digits multiplied by their respective powers of 2. This system is preferred in computers and digital devices due to its efficacy to represent information with two states. Understanding and conversions between binary numbers and decimal numbers are key concepts in computer programming and coding. Binary numbers are composed of digits that each represent a power of 2, starting with the rightmost digit 2 to the power of 0 and increasing in power with each subsequent digit to the left. For example, the binary number 1101 is the decimal equivalent of 13. To calculate the decimal equivalent of a binary number, we need to add up the values represented by each of the binary digits. For instance, the binary number 10,110 is the decimal equivalent of 22. Being familiar with binary decimal conversions enables us to solve complex math problems and develop better logical thinking skills. To convert a decimal number to binary, a simple method can be used. Start off by dividing the decimal number by 2 and make a note of the remainder. Divide the quotient by 2 and record the remainder, repeating this process until the quotient reaches 0. Then, compile all of the remainders in the correct order to get the binary equivalent of the decimal number. For instance, when converting 25 to binary, the process would look like this. Dividing 25 by 2 to obtain a remainder of 1. The quotient is 12 and dividing this by 2 yields a remainder of 0. Repeating the same steps until the quotient is 0 results in remainders of 1, 0, 0, 1. By reversing the order of these remainders, we can see that the binary equivalent of 25 is 11,001. The octal number system is a base -8 numeral system which is frequently used in computer programming and digital electronics. It is distinct from regular number systems as it consists of 8 digits, which are 0, 1, 2, 3, 4, 5, 6 and 7. This system is built on the powers of 8, with the least significant figure representing 8 to the power of 0, or 1, the subsequent figure representing 8 to the power of 1, or 8, and so on. As an illustration, the octal number 237, when expanded, is equal to 2x8 to the power of 2 plus 3x8 to the power of 1 plus 7x8 to the power of 0 equals 128 plus 24 plus 7 equals 159, which implies that the octal number 237 is equal to the decimal number 159. Octal numbers are an important tool used for computer programming as they allow data to be converted into digital form. To convert octal numbers to decimal, the positional value system used in the octal number system needs to be understood. Each digit in an octal number stands for a power of 8 starting from the rightmost digit, 8 to the power of 0, which is 1, and moving to the left, for example 8 to the power of 1, which is 8. To convert an octal number to decimal, each digit needs to be multiplied by its corresponding power of 8, with the results added up. As an example, for octal number 345, 5 times 1 equals 5, 4 times 8 equals 32, and 3 times 64 equals 192, giving us a total of 229 in decimal. The binary representation of numbers is used often in applications like computer programming and coding. Octal is another representation of numbers, and it can be converted from decimal to octal. To do this, divide the decimal number by 8 and keep track of the remainders at each step. The remainders will be the octal digits in reverse order. Let's look at the example of converting 1234 to octal. Following the same steps, we get the octal representation of 1234 as 2322. This is the process of decimal to octal conversion. Hexadecimal is a complex yet powerful way to represent numbers. In hexadecimal, numbers can be expressed in 16 symbols. Ranging from 0 to 9 and A to F, it is used to represent binary numbers in a much simpler way than decimal numbers. For example, A is equal to 10 and F is equal to 15. By simplifying the relation between a base minus 16 and a BASE2 number system, the hexadecimal number system provides a great tool to solve complex math problems and to improve logic thinking skills. Hexadecimal to decimal conversion may appear difficult at first, but with some practice and an understanding of place values, it is actually quite easy. For instance, the hexadecimal number 2e can be converted into decimal by multiplying 2 by 16 and adding the result to 14, which would equal 46 in decimal. With the proper technique, it becomes a breeze to convert hexadecimal to decimal. Converting from decimal to hexadecimal is an easy process. To do this, we first divide the decimal number by 16 and record the remainder. If the quotient is still greater than 16, repeat this step until the remainder is 0. Then, represent each remainder as a hexadecimal digit, using numbers 0 to 9 and letters AF. For example, when converting decimal number 345, the hexadecimal equivalent is 159. To convert from binary to octal, group binary digits into sets of 3 from the rightmost digit. Add any necessary zeros to the left, and then assign each set of 3 binary digits a corresponding octal digit value based on the table of values. Combine the octal digit values to get the final octal number. For instance, 110,101,011 when grouped into sets and assigned the corresponding octal values yields an octal equivalent of 325. Octal and binary numbers are significant in computer programming and coding. To turn an octal number into binary, each octal digit needs to be converted to its binary equivalent. This can be done by consulting a table that shows the binary equivalents of each octal digit. After performing the conversion, combine the binary digits to obtain the final binary number. For instance, if we want to convert octal number 345 to binary, octal digit 3 is equal to binary digit 011, octal digit 4 is equal to binary digit 100, and octal digit 5 is equal to binary digit 101. Consequently, the binary equivalent of octal number 345 is 011100101. Converting binary to hexadecimal is a helpful tool in computer programming and coding. It makes it simpler to comprehend and work with binary numbers by changing them into more understandable hexadecimal numbers. One approach involves breaking the binary number into chunks of 4 digits and relating a hexadecimal digit to each group. For instance, the binary number 110,101,011,101 can be broken down and changed to hexadecimal D5D in hexadecimal. Another way is to convert the binary number to decimal, then from decimal to hexadecimal, which may be easier for someone dealing with longer binary numbers. Understanding how to convert binary to hexadecimal is an invaluable skill that can help simplify computer programming and coding. Converting hexadecimal to binary may look difficult, but it is in fact quite straightforward. At Gurukulplex, we provide help so that no one is left behind. We will explain to you how to get the binary equivalent of any hexadecimal number. We will show you how to divide each hexadecimal digit into its 4-bit binary form and how to group the binary bits from right to left, including adding leading zeros when necessary. After this, you will have a clearer picture of how these two number systems interact, and you will be able to convert hex to binary with no problem. Binary and decimal numbers are essential components of computer programming and coding. Binary is the language computers use to represent data, and it is important to understand how to convert between the two. Hexadecimal number systems can also be used to encode and decode messages, allowing for efficiency in tasks such as cryptography. These number systems are put to use in everyday applications, ranging from programming to cryptography, offering invaluable aids in problem solving and improving logical thinking. We have explored the 3 different number systems: decimal, binary and octal, hexadecimal. We discussed their properties, how to convert them and their applications in the real world. Understanding and working effectively with numbers has become an integral part of our lives. It allows us to communicate and process information quickly and efficiently. With a better understanding of number systems, we can expand our skills and deepen our knowledge of the world around us. Our journey into the world of numbers has been an informative one. Thank you so much for joining us on this journey. We hope you learned something new and were able to improve your logical thinking skills in the process.